Hey everybody, me Keith, Elder Rock, back here with another video from Arcade Laboratories. This is not an arcade repair fix. I'd probably put this more under maintenance. Today's video, we're going to go through composite signal dissection and discussion. I'm going to show you what a composite signal looks like on the O-scope, how to set your O-scope up to capture the two important events to make sure your composite signal is looking good. And hopefully you learned something. There's still a very old technology. Composite signals was engineered in the 40s when TVs first started broadcasting. It was a way to send a picture, send your TV over the air, RF kind of stuff. So the first, I call it the first version, was black and white. So the first composite signal set was black and white. Then in the 50s, we come up with color TVs, and they modulated or interlaced or embedded color signals into the broadcast signal. And that allowed the TVs to scan and display color without the manufacturers having to retool or re-engineer or create new components at the time. So that's the purpose of this video, and we're going to follow up with a bit of practical exercise and maybe a repair. So yeah, I'm here in Thailand and I'm getting my bench set up for some board repairs. I have some RGB mods, CRT RGB mods coming from my friend Steve that he engineered. We're gonna test them, install them, and I thought I'd like to do a little series on video signals, the different kinds. So today, I guess we'll get out of the way the composite signal. It's the oldest, and it's still used very much today with retro gaming, in the PC world, CCTVs still in use that use that the good old-fashioned yellow. The good old-fashioned yellow plug. Yeah, good stuff, old stuff. But still used today, and if you have a lab or a bench, or if you have equipment malfunctioning, after this you should be able to hook it up to an O-scope, check out your signal, and make sure that it's okay. Okay, so let's spin around here. We're gonna take this time. I'm gonna show you what's going on with my setup here and why we are doing this. So let's flip the camera around. So basically, I bought for testing my CRTs. I got a handful of them here in my room in the lab to test the composite signals. I got a Sega Mega Drive. It has S-video and composite. So anyway, I got this adapter. I bought this adapter, some Mega, what's it called? Mega SO2. So basically it should output composite and S-video, and the composite is not working at all. So let's, I'm going to plug this in, and I'm going to show you what we're getting on the screen. And this is a good practical exercise. You could run into this with some old devices that you have. Maybe you're not sure if your composite is working okay. Is it the device? Is it the device, or is it the cable? What is it? Now check that out. I just plugged in that composite from that adapter, and you can see there's like no sync. I don't know. I haven't looked at that signal yet. I'm waiting to do it with you. So let's look at a good composite sync on the scope. Then we're going to look at this. Then we're going to look at this one under the scope, see what's missing from what we just learned, and we're going to open that up and maybe have a repair. That would be awesome, right? So I'm gonna put you on the scope here while I get these cables. Get this the good composite connected back up here, and let's okay. Yep, I think we're looking good. let's get this guy hooked back up. I apologize taking up your precious time, and I do thank you guys for hanging out and watching my videos. Okay, so just for testing, good composite signal. Okay, that's the signal that we're going to look at and talk about under the scope. So kind of a tricky signal to get at on your scope, but not impossible by any means. So let's so what I'm doing, I'm just hooking my probe to the center pin. I don't have a 75 ohm. I don't have a 75 ohm resistor between my ground and my video. So I think we might have a little interference, but the signal will still be decent enough to look at under the scope. Okay, there we go. I already have, I'm going to shut the light off. Okay, there we go. 6 minutes in, and we're actually just finally getting to the scope. Okay, so a couple things to look at here. So looking at the synchronization element of a composite signal, there are two different parts that you need to keep the display on the same timing as the source. So pretty much your TV, your chassis and your TV, it's doing, I call it, let's just call it decoding. It's doing decoding and synchronization based on its crystals, its clocks internally, and also the TV itself's DC input. And so what I mean by that is in NTSC, America and Japan, we have 120 volt AC mains. So that AC is actually that the 60 hertz, the 50 hertz for POW, that is directly proportional to your syncing of your signal, whether it's composite, component, HDMI, S-video, uses that frequency from your main DC to decode. Now, your video signal is going to contain two important components. It's going to have your individual scan line and sync, and it's going to have your vertical blanking. So let's kind of take a look at talk about what we're seeing here. Okay, going for my pointer. Okay, so what you can see here are line pulses, line sync pulses here and here, and if I adjust it in, you see them. So these are your sync pulses for every line. So just kind of the anatomy of what we're looking at. We have what you can see right now without me zooming in. You have your sync, you can see your color burst. This is your line information, and then coming to your next line. So let's zoom in a little bit on that and get you over here. And we did not, I blew right by setup. But I'll show you the settings here in a second. Okay, so just kind of blew up a little bit on that, on this sync pulse. So the terminology here, back porch, front porch, sync pulse, not sync pulse, no, color burst, excuse me. Okay, just to kind of go over that again. Front porch, back porch, color burst, and then your beginning signal. Now, this is kind of an important part of what's happening here. So at this level here, it's pretty much 0 volts. It might be, I think it's just down, I think it's a negative voltage here a little bit. And pretty much it separates your picture information from your sync pulse. So right here, nothing's happening. No picture, no sync, no image. Your gun's not really the gun of your TV, I'm talking, is not really doing anything. Okay, so directly after the back porch is a short period of sine waves, and we call those the color burst. So the color burst is a frequency of the color subcarrier. So basically, this is a reference for the oscillator to use with your picture information. So it's going to use your color burst as a sine wave reference to your picture information, which are also sine waves, and the offset of those sine waves are going to determine your color, and the magnitude or amplitude is going to determine your hue or brightness. So the higher the amplitude, the brighter the color, and as these sine waves offset from each other from the reference color burst, give you your red, green, blue, purples, chromatic, all of that good stuff. Okay, so I think that's about it for that as far as I'm going to go for today's video. But I think another thing, the sync pulse 0 volts is giving the scan line time to go around and restart the next line coming through. Okay, so how did we set this up? So to capture this, at least on the Regal, right now, you can see, well, I was going to show you, I had, let's get this back in, oops. Let's get this back in. I did have my cursor set so I could show you the frequency. So I have my cursor set, and for the sync pulse, for line sync pulse, and it is sitting at 15.77. So pretty close to 15.73, which would be perfect. So that is each line, and this is the color information. So I wanted to show you guys, talking about the color information. I'm going to reset the sync source, and I know we're sitting on, it's going to go black and then blue. So on the video information, black is more towards 0 volts, and white is more up towards the top. I think a little over 1 volt, 1.38 volts right now. So let's power cycle. Okay, so you can see black, boom, and then blue. With blue is the phasing is probably in the middle there, and then these higher points would be the white lettering on the screen that's displaying right now. So okay, so that's one component, or yeah, one component. That's definitely one component of the composite signal. And let's look at blanking now. Oh, before we do that, let's look at the O-scope setup. I'm sorry. Okay, so what I use on the Tektronix, if you go, let's zoom out, under the trigger menu for types of trigger, you have your normal edge, pulse, slope, pattern. A lot of the newer ones actually have a video trigger, and source channel 1, polarity. I like to use the trigger on the falling slope, because I think the first what we're doing, we're trying to set up the trigger on this color burst. And all lines, NTSC. So let's stretch that out a little and kind of look at that trigger. What we're trying to trigger on. We're trying to trigger on the color burst right there. Let's take our trigger level into that guy. Now let's see, we get our trigger off of that burst, and then, you know, it's not triggering. So when you set it up like that, just make sure your trigger is probably going to be 0-ish volts. Let me get let's get everything centered again. Yeah, it's actually going to be in the negative a little bit. So just make sure your trigger is kind of there. And I like to, like I said, I like to do the negative pulse because that first color burst you can see is going down. So falling, it falls slightly, just ever so slightly, and then off. So on these guys, I think 9 to 12 pulses for the color burst. Let's count at least 1, 2, 3, 4, 5, 6, 7, 8, 9. And so when you choose your line, sync all lines, video. I thought there was standard. I thought you actually entered in, or you can go line 7 pulses, which should be kind of close enough. There we go. I got a better, but see, it's only, okay, so now we're only triggering on the frame. We're going to be triggering on the frame blanking. So you could do that too, I guess, but some of your measurements are going to look a little different. So let's actually look at this. This is actually the next component of the composite signal, and this is going to be your vertical blanking. So this is the signal that tells it when it's done writing one full frame, and you get down to the bottom, your 480, or it's a little bit, it's more than 480 lines because you got some off screen. It shoots, turns off your gun, and shoots you back up into the top left corner. So that's what this signal is doing here. So let's talk about this. Let's talk about the blanking signal. But I actually want to trigger on it a different way. I don't really actually know if I need to. But I'm going to show you the other way I trigger on it. So the other way I trigger on this, because I know these pulses are I don't know, like I go like 0.35 milliseconds. So what I do, I go I just go regular pulse. I just go regular pulse. Channel 1. I already have it set up for, it's a win. W-H-E-N, win. So win, the symbol right there. So it's basically going to look for pulses that you specify. A win pulse and I go 3.3, 3.34, something like that. And then now you can see we're triggered. And I like this way better because you can see the actual line, the individual scan line information. Like if we were to break that down, so if we were to spread that out, there's the line sync that we just looked at. So, and I think it's pretty cool because if we were to go through, so this is your vertical blanking area right here. So this is what we're going to talk about next. Let me get it where we can kind of see it a little better. I like this view better using the win because you can see your video information. You can see the last frame, not last line of your frame being written, and then we are going to sync, and it's going to alert the decoder and the gun and your TV to go ahead and move, start writing your next frame. Okay, and some interesting things here going on with the vertical blanking. Saying that right? Vertical? Yeah, vertical sync pulse or your blanking sync pulse. And that's what's going on here. And so you'll see that this pulse gets pulled low, but there are inverted lines. And this is for the oscillator, your sync oscillator in your TV can keep time. And during this time, again, your gun shuts off and is repositioned. So I like this view because I haven't done it, but you can see you're sending your gun electron back up into the corner, and then if we scroll, you can see, we can probably zoom in a little bit right here and see that's probably the beginning of your pictures being your frame line by line being written, amplitude and phase determining the color. So right now we're sitting on a pretty just a blue screen with some white lettering. Let's see if we can find the white lettering. So this is going to be the top coming down, it's scanning, boom, right here we got white letters. There's where it starts writing each line, not really a pixel. You can think of it as a pixel. That's what pixels are, kind of more of an idea than a thing. But you can see the lettering on your O-scope. There's probably space in between the next sentence, more space, and so on and so on. Now if we were to, let's zoom way out, and now we can see complete frames. This is one frame, and the next frame, and the next frame, complete frame. And then you can see every time it rescans up to the upper left corner. So I haven't done it yet. I should. I'm guessing there's like 500 individual lines there, what we just looked at. Okay, so I'm going to leave a link below to the more in-depth of what I've talked about. That's just kind of the quick overview. Since this is kind of a practical, we're going to go practical now. We're going to take a look at that other bad component signal and see what it looks like. So let's go ahead and let's set back up. Let's set back up to look at the line scans, and we're going to take it 5. Yeah, can you see my 500 millivolts and maybe just this thing out. There we go. Let's center all that up. Okay. So there is one line. There's a pulse. Let's get 2 pulses in there. So there we go. That's close enough. We can see the anatomy is there. We have our pulse signal. We have our porches. We have our color burst. We have color. We have blue and white. So let's go ahead and hook up the bad signal together. First time. I've been waiting like a whole week to do this video and look at this signal, but I wanted to do it with you. So, you know, I like book work, but I like practical stuff too. It's like, why do we do this stuff? Okay, so there we go. We're disconnected, and now we are gonna connect up the bad composite. Oy. Look at that garbage. We even on? Yeah, we're on. Wow, there's nothing there, guys. I didn't think there was anything there. But remember from the beginning of the video, the screen, there was nothing on it, really. I do see some spikes on there. Let's see if we can, geez, let's auto that. There's definitely no color burst there. It's not triggering on anything. Okay, let's zoom out. Let's just go normal edge trigger, source 1. Yeah, let's just trigger on a rising edge and see what happens. Yeah, we're in there. We're triggering on that rising edge. Wow. Let's see if we can do a single. Okay. There, I just did a single. Let's see if we can measure a couple of those pulses. I don't even have enough bandwidth on that guy. Let's see if we can get 2 of them in there. I want to measure that spike. I bet that's a pulse signal. I want to measure that, but we don't. Why is it? Okay. Well, let's zoom out. Let's run that. Let's single trigger that. That's good enough. Okay, let's get our cursors. Let's go cursor B. I'm going to zoom in here now. I'm done adjusting. So I just want to measure those and see what the frequency is. Okay, then come cursor A. Cursor A. Yeah, check it out. We are sitting at 15.82 kilohertz. So that is definitely a pulse signal. But remember what we just learned? Yeah, there's nothing else. We've got some weird pulse, but there's no color burst, there's no color information, there's no front porch, no back porch. There's nothing. There's nothing from this guy. So let's get this guy. Shut him off. And let's get this guy taken apart and let's look at him a little bit closer. Yeah, this is just, I know it's not arcade stuff, but it is practical learning, so I'm all about that. Let's get my tripod, my little mini tripod here I'm going to turn back on the light. I'm going to zoom out a little. Hopefully my tripod don't. What do we got here? Okay, let's, so it could be a broken trace, a corroded trace, a cut trace, something. Let's get that guy apart. I actually bought this thing from a friend of mine who has the shop in Bangkok. Hooked me up. He's got all kinds of cool stuff. He did not have an RGB one that I wanted, but I have another solution coming for that in the mail from my other friend, over at Frankencade. I call it Laboratory, but he's Frankencade Arcade, I think. But he's a pretty high-speed guy. And I'm getting some RGB stuff from him. I don't really want to buy a PVM here. So my plan is for my test setup for the arcade boards, we're going to get a commercial console and RGB mod it, and then that will be the monitor I use for the PCB boards I have. Okay, what do we got here? Gotta be careful. All right, there we go. All right, what do we got? I am going to try my best, guys, to get you guys a good view. Okay, let's see. The PCB looks okay, so what I'm doing, I'm giving it a visual inspection before I even flip it over. I don't know what this thing even is, first time ever looking at it. And Okay, there's a big old custom chip right there. Look at that guy. That guy right there. Darn it. Probably resistors and capacitors in there. And there is a chip. What is that guy? It's an MC 13077. Could be an op amp. I don't know. I'll pull it up here in a second. I was hoping to find something silly like... a broken trace, something like that, something easy. Like, why isn't that thing outputting component? Where's my... yeah, those header solder joints look okay. I'm looking at the component here. Let's just kind of start looking at him. See, where does he go? It looks kind of gnarly on top there, but I don't think it's cold solder. I think if it was cold solder, it would have been flickering more, trying to make a connection. That's just like some, well, maybe, I don't know. That's pretty gnarly there. Tell you what, guys, I'm going to pause here. I'm going to get a couple tools and look at this because my tripod's right in the way, and then we'll be back in a second. Okay, so we're back. I cut away and I went away and did some probing around on this thing, so this video wasn't going to be like 4 hours long. Okay, so basic troubleshooting with anything. So we knew we were not getting that composite video out of our composite. So took the thing apart. We're calling that our source signal. This is where our source signal was supposed to come from, right? So first thing I did was just kind of some basic continuity checks and found that the composite, it actually comes around right from the header pin, right from the cable, right from the Mega Drive, our true source. This is just an adapter. This is kind of like some real life stuff. Yeah, I got the have it all tore apart, taken apart, because I'll show you why here in a second. So going through this, realized that none of this circuitry on here is for converting. None of this circuitry on here is for converting the composite. The composite is native from the source. And as far as S-video, what's native from the source is RGB into the adapter, and the chip, the video processor chip, converts it to S-video, and we have our S-video. Now, kind of running it around, I traced that back, right? Traced it back to, it's a direct shot. So without any components, from the component right to this header pin, right to the orange wire, So let's probe again on the orange wire. And that is what we have instead of our composite. So I pulled up some pinouts. I got some pinouts going of the Mega Drive. And if anything you're troubleshooting, I mean, this is going to be kind of realistic to how you're doing it. So I did map everything out. I mapped everything out and realized that, like, basically that orange wire up to here is actually going to the mono sound wire. So that signal that we're looking at there is actually mono audio. This thing puts out mono left and right audio. So the pinout of this cable is completely wrong. I don't know what they were thinking because they could have used the circuitry on here and build it out. So I want to look at that chip. It's actually pretty cool. Part of the troubleshooting. Let's see. So this is a color television RGB to PAL NTSC encoder. So basically it will generate a composite signal. It will generate a composite signal from RGB, and it will do other things. So I was looking at the pinout on this guy and looking at this composite out, pin 9 composite out on this chip. Let's look at it here. Pin 9. It's flat. It's not outputting anything. And then also on the board, it's not connected. And then so the composite sync input, the input is on pin 2, and you can see we have a composite input, the right amplitude and everything on the input. But if we look at the flow chart, the composite sync input, it is connected to the composite video output through an op amp and these clamps. The clamps are basically just gonna set your levels, set your B, your Y levels. So but it didn't matter. It don't matter in this situation, because for a composite, none of this circuitry is for composite on this particular adapter. So yeah, just trying to keep it simple and practical. So what I thought I could do, since the pinout is wrong, so basically, let's go over to the other pinout and I'll show you. So basically, what they have going on, see video, composite video, pin 4 is dead, empty, not populated. And they have, what pin? Oh crap, what was it? They have pin, oh boy, I lost my train of thought. Oh, they have the mono, okay, I'm sorry. They have mono pin 6. They have mono audio pin 6 built into this cable to come down into the audio, or to the composite video input, which directly is a pass-through for the output. Never going to work. So what we seen on the TV was actually audio. So that's kind of why I took the Sega apart. I was thinking maybe I could, if I wasn't sure what 6 was, when I took it apart, I was thinking I could put a jumper from 4 to 6 and use both cables and the adapter, but you cannot. 6 is already spoken for on the source as mono audio. So unless you wanted to build a new cable, a new dongle, that's the only way to truly fix this thing. But for today's learning exercise, I think it was a good learning exercise, because was able, you know, if you're looking for composite, you know, you can just run down through your pins. Now you guys know what your composite signal looks like. And we're going to get into these in another video. RGB and sync. There's your RGB and sync. Well, sync is in there somewhere, and audio. So I don't know how much longer I really need to make this video. And if we check our source, we can check our source again. We can check our source. Yeah, good composite right from the source. So as soon as it don't even connect. So that pin goes to pin 4, which is not connected, and that's why we didn't find any composite sync native down here. I trying to figure out what they were up to when they designed this board, because they could have used this circuitry and got a composite output. But another thing I wanted to show you about, I'm not sure about, and something that's just kind of tricky. They, you guys international playing with internet, global PAL-GAL, NTSC signals. There was, where's it at? Pin 20, NTSC PAL Select. So basically when pin 20 is grounded, it's NTSC. When it's not grounded, it's PAL. So if we go to pin 20, obviously not grounded. We have voltage there. So I'm not sure how, I don't think that's the problem because of how the PCB is hard-coded. But right now this thing is in PAL configuration. So that has to be grounded. And this is an NTSC source. So just something to keep in mind when you're working on video equipment from around the world. You've got PAL-GAL TVs, PAL-GAL, you know, that one might be only PAL. This one might be NTSC, and you might have a variety of different devices that you need to connect. So if you get goofy signals, you know, now you guys know how you can come with your O-scope and kind of check it out. Now I didn't get into the PAL signal. They operate pretty much the same. You're going to have different frequencies and different amplitudes, but the waveform should look pretty similar. So that's kind of what you're looking for when you're doing that stuff. So kind of a convoluted video there, but I hope you guys learned something, and I enjoyed making it. And I will put the links to the source material where I got the material. A couple good videos that if you want to spend time just studying the waveform, I'll post the links below, and they're really good. But I wanted to get kind of hands-on, show how to set up the scope, how to capture that waveform, because it's a little tricky if you just try to use your normal rise fall triggers on your scope. So that'll be it for this time, and stand by. We got more to do. Yeah, we have more videos to do. A sneak peek. We're gonna recap this one. We're gonna recap that next. We have some vertical collapse. Okay, see you guys later.